Hi, Mr. Pope.
Hey, what's going on? How are you?
I'm good. How are you?
Woo, pretty good. How was your break?
It was good. I
Yeah,
got
but
dressing, so
heck yeah, I was gonna ask, did you get anything delicious? So let me ask you a question. Was the dressing cornbread based or white bread based?
cornbread.
Only way to go.
Oh
Only
yeah.
way to go. Have you ever spent Thanksgiving anywhere outside of Texas?
Nope.
Okay, well, as I don't, now that I think about it, I don't think that I have either, but I have spent Christmas outside of Texas and had dressing. And in the north, they use white bread for their the base, and I don't understand it. I'm just like, you're using white
I've
bread
never
instead
heard of
of corn.
anybody doing that.
Oh yeah, well, you get anywhere probably. I don't know about Kansas, but let's just say Nebraska in the Midwest, and then points. It might actually follow maybe north of Missouri. I don't know, maybe Illinois, Iowa, and then out towards the northeast. They use white bread, dude. It's crazy. And it's like, what?
Did it taste
Gross.
good?
I mean, it tastes like dressing, I guess, but it doesn't have, it's more dense. Like if you have, I don't know, do you make dressing yourself? Have you ever been involved in the process of making it?
Yeah, but not like heavily.
Okay, well, I like to cook, and so whenever you make cornbread, you take the cornbread the night before you make it, and then you take it out. Oh shoot, turn that down. And you dry it, right? So you take it out of the pan, you put it in the oven, you let it dry in the oven with the residual heat that's left over from cooking it. And then the next day, you take it and you break it apart and you mash it with your hands, right? You're macerating all this with your hands. If you blend it too much, it gets real dense. If you just kind of break it up with your hands and massage it all in there and kind of stir it with your hands, you're not making the particles too small. And so if you're not making them too small, they can't pack together very well. And so those particles of white bread are really, really fine particles. So they stack together. Think of it kind of like clay. Like clay is just dirt. It's just really small particles of dirt. And because they're so small, they can pack together really, really tightly. And it's terrible. It's the consistency. It tastes fine. It's just the consistency is off, and you're just like, I don't know. I like
Do
a
you
really
eat yours?
coarse. Hmm?
Do you eat yours with cranberry sauce?
Heck yeah. What are you talking about? Who are you talking to? Do you eat yours with cranberry sauce?
Yeah.
Oh, of course. What are you, man? Who doesn't? Yeah.
I know some people don't like it with cranberry sauce. I don't understand.
We make our own cranberry sauce too. We
Oh
make
my
our own.
gosh, my mom does.
Wait,
Heck
what?
yeah. Yeah, we make our own cranberry sauce here. What?
Ugh.
I don't want that. I don't want that jelly crap out of a
For
can.
real, canned cranberry sauce is nasty.
I mean,
Right.
I'll eat it. I mean, I think it's fine, but I'm not gonna. It's nothing like homemade cranberry sauce. I put pecans and I take orange zest, and I take oranges and the orange peel and I zesty and I take a little and I shave it into the mix, and then I take cranberries, I put them in a blender, and then I take orange juice and I squeeze it into that blender and then I blend it, and it's delicious, man. What are you talking about, man? It's fantastic. Any of you other guys make your own cranberry sauce? We still have 1 minute before we begin. Nobody else makes their own cranberry sauce.
Earl
What?
doesn't like dressing at all.
Because Earl's an idiot. He does. What are you talking
Stuffing
about?
is
Did,
nasty, bro. Oh
dude,
my.
Earl takes a $10 gift card and then buys 1,000 pieces of gum, chews it up, and makes art with it. What's wrong with Earl?
And then I chew it again.
And then you chew it again. Now, Earl, didn't you run for student council?
Uh, Last year, yeah.
Yeah, and you're student, and were you president?
Yes. How do you know this?
Maybe I keep my ear to the ground. I know everything. I'm like Santa Claus, dude. You're on my list. I know these things. So your friggin' president doesn't eat dressing and cranberry sauce. What's wrong with y'all?
Maybe
How
I
can
just never had any good like dressing or
man?
cranberries.
Okay, so Earl, at my house, I live at 1706 Nueces, Nueces. Do you drive?
Yeah, no,
Oh, what's
not
wrong with
yet.
you? Oh my God, y'all don't drive either. Something's terribly wrong with you. Anyway, my address, if you can get over here, is 1706 Nueces, Nueces Trail. I only live like 10 minutes from you. You want to eat some delicious dressing? I've got some in the refrigerator. I've got one serving left. It'll be here for about 3 hours, and after that, it's gone. I'm eating it.
Okay.
All right, but you gotta get here within 3 hours because after that, it's toast. I've got enough cranberry sauce left over. All right, it is time. We're going to begin class. Let's see. There's only 19 of you guys, or 18 of you guys have shown so far. If you're missing it, no big deal. I've got it recorded. Okay, so today's, I'm just going to do some reminders, right? So today we have the cell exam retake, and it's from 2 to 4 o'clock. I had 14% of you guys actually took me up on the offer of retaking the biomolecule exam for Q1. That window is closed. I just got through grading all of them. They're all graded. I've changed the grade book. I'll have to file a grade change for those to show up. They won't show up until next semester on your transcript, but they will show up. I promise. I'm done grading them. Today I'm going to open this. Yesterday I opened it at 1. Today I'm going to stick with 2. I told you guys 2 o'clock. I'm going to open it at 2. I'm going to close it at 4. They're not allowing me, and for whatever strange reason, to come in and meet with you guys to open it. I'm not going to buck that system. I am going to stick with my promise that I would offer it, and because I'd already made that promise to you guys. So that is going to be today. I'm going to show you where to find that in just a moment. The other reminder is that 6 days from now, you're going to have your endosymbiosis presentations. I sent you guys an example in the email. A lot of you guys had asked for that. I'd never have given people examples in before, mostly because I just don't want them copied. I always like to see something different. I think you guys will also like to see something different as well. So we're going to view these next week when you guys come to class. You're going to have the links for them. You're going to drop those links however you guys have put them on YouTube or however you've uploaded those. You're going to drop them in a link. We're going to watch them, and then I will grade them as we watch those. You're going to also submit that rubric. Before we have class today, I'm going to show you where to find the cell exam, and then also I'm going to give you guys 5 minutes to meet with your groups so you guys can discuss any last minute details, and you'll have 5 minutes to do that, and then we're going to get into today's lesson. So I'm going to stop sharing for a moment. I'm going to show you where you can find that test. Man, you guys are all coming in about 5 minutes late today. Okay, so here we are. This is your class. Yesterday, this is where you would have found biomolecules. Today, you'll find cells here in Unit 2. There is a retake here somewhere. I can't remember where I have it in here. I think I had it right here, but this is the new retake, and this is a new test. Yesterday, I threw you guys a bone. It wasn't that difficult for the biomolecules. This one is going to be a little different. You'll come here and you'll click and you'll find it. It's there. So that's where you'll find it. You can go there and you can find it under Unit 2. It's in bold letters where it says cell retake. You can't see it if you click on there now because it is literally a unpublished exam. I'll publish it at 1 o'clock and then you can view it. Okay, in the meantime, let me pull up your groups so that you guys can you guys already see your groups, or do I need to change my screen? Can you see your groups already?
No.
Just no, all right, hold on. Thank you. All right, here are your groups. I need you guys to change your names in on the Zoom call. So like Juliana has her name is just Juliana. Change it, put a number 1, 2, 3, 4, 5 to correspond with your group. I'll give you guys 1 minute. So in this case, it would be like Juliana is, let's see, Juliana, where are you, kid? Oh, you're group 3, so you would put a 3 in front of your name. So go ahead and change your names on your Zoom call so I can drop you in the appropriate group, and you'll have 5 minutes just to discuss anything that you like. Just to discuss anything that you like about the project before you guys present in 6 days. Dun, 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 dun. And I'm gonna start moving you guys now. 3, Tabitha, 3, Precious, 3, Tarleton, 1, Leal. You're in the right group, Leal. Good. Matthew Medina. Matthew Medina is group 1. Sabrina, group. You're in the right group already. Tabitha, in the right group. Mock, you're group 1. Nia, group 1. Romello, 4. Emma, 3. Taylor Tubbs, 5. Abby, 2. Lazaria, 2. All right, nobody else has got any other number in front of their name. You need to change your name if you want me to drop you in your group to correspond. So for an example, it says Matthew Medina 1. He is in group 1. So I put him in a breakout room for group 1. I am putting you in breakout rooms so that you guys can discuss any last minute details. There was a few people that asked if I could put you in breakout rooms so you could just kind of discuss and iron out any little details that you, because you guys have had a tough time getting all of your group members all at the same time to meet. So this is a chance for you guys to iron out any last minute details. I'm gonna open these rooms now. If right now, Reggie, you don't have anything in front of your name. Ariel, you don't have anything in front of your name. Jalen, Mariella, Daisy, Daniel, Safe, you have nothing in front of your name. You're not going to be in the right group. I don't know how to change my name, but I'm in group 1. Somebody, all you need to do is just, I believe, what are you guys doing to change your name? Just tapping on the name, correct?
You click on the 3 dots and then
click on, oh, that's right. Yeah, click on the 3 dots on the right corner of your name, and then you can change it. You can change it. So that's how you would change it. So there's a few of you guys changing your names now. Click on the 3 dots in the top right corner and then change your name. I will open these up in 1 minute. Okie doke. And
didn't work.
I got you sorted. Chavez, I've got you sorted. Daisy, I've got you sorted. Reggie, thank you. Got you sorted. If you're just joining us, you're putting your name and the number that corresponds with your name. You're changing that group. So if you're group 1, you would put, in this case, Aspen Jenkins, whatever group you're in. That would put you there. All right. Looks like I've got everybody that has put a number in front of their name. Safe, you haven't done it, so I don't know what to tell you. Adrian, you haven't done it, I don't know what to tell you. Juliana, your group. The sheet's right here in front of you. It's right here. I'm sharing my screen. You can see your name here. All right, there you guys go. You have 5 minutes. If you haven't put your, change your name, I'll look for you while you're in a group and see if I can't sort you out from the list. All right, there you go. Cameron, I don't see your name on this list. You may have had your name, your group changed at the beginning of the year. Who have you been meeting with? So I can drop you in the appropriate room. You don't know. I'm going to drop you in group 1 because I know that they have, see if they can't give you something to do. And I'm actually, Aspen is not in that group. I'm going to put you in group 1. Hold on. Aspen is in group. Juliana, I've got you in group 3. You're good to go in group 3. Yeah, I got you in group 3 now. Juliana, you're in group 3. You can join. You're in the right group now. Just join. What's up, guys?
Hello.
Hey.
Bryton's
Mr.
in
Pope,
the wrong room.
I think I didn't get the instructions clearly. I didn't understand them.
Okay, so
I'm
what group?
4.
You're group 4?
Yes, sir.
All right, let's see.
I believe I'm supposed to be with Earl and
There you go.
I also know we're missing Tristan, I think, and that's it.
I don't think Stein's here. I haven't
Oh.
seen Stein in attendance. All right, you guys have about 2 minutes. Just discuss anything you need to. Stein, you're group 5, correct? Jump into group 5, Stein. You guys jumped out early. You still had another minute, unless you guys ironed everything out.
Yeah, we did.
Okay, good deal, good deal.
Yeah, we did too.
Okie dokie. Good. I'm excited about you guys' presentations. I can't wait. How in terms of percentage, how far would you guys say that you guys are from finishing?
Like 25.
25% of the way from finishing?
Mm-hmm.
Okay, cool, 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 cool. We'll wait till everybody, all right, everybody's here now. Question for you guys, and please do use your audio as much as possible today. Question is, why do you breathe? Why do you breathe?
To fill your
Yeah.
body with oxygen.
To get oxygen?
To not die.
Stay alive.
To not
To
So
live.
we don't die.
Yeah, okay, so why does breathing keep you alive?
It supplies your cells with oxygen.
So why do you need oxygen?
Cellular respiration.
Why do
We
you
were
need
just
oxygen?
created that way. We were created that
Doesn't-
way.
Oh, you were just
Doesn't
created
the
that way. That's
Oxygen
cool.
go to your blood.
Okay, so why do you need oxygen in your blood?
So our heart keeps pumping.
So why do you need oxygen in your blood for your heart to keep pumping?
Because oxygen does the job.
Because oxygen does the job. I love it. So I'm going to give you an example. The other day, this was last spring. I'm down at Lake Arlington at the Arkansas ramp. You know, there's Arkansas Lane. It terminates into the lake, and there was this guy fishing with his kid, and the kid caught this little sunfish, and the kid saw its gills, and the gills are red, and this guy says, or this little child says to its father, I'm assuming its father, could be its uncle, neighbor, somebody, that says, why? Oh, look at the gills. They're red. They're red. And they said, why are the gills red? And I'm assuming father says, well, the gills are red because the gills are red, baby. And I thought, great. That's great. That's to me, I think that was an opportunity for that, you know, that parent. There was this kid that asked this question, why are the gills red? And the thing would to have said was like, I don't know, right? And then go home and try to figure that out. Why are the gills red? And see if there's an answer to that. There's answers to everything. So the question is, why do we breathe? Well, of course, yeah. Go ahead. Who was it? No. Okay, there's questions. So I knew that you guys were going to say oxygen. Why? And then I wanted to know.
This imposter. I'm just joking.
What's up, man? There, I'm back. Sorry about that. That was terrible.
Okay. Don Leah was teaching us about why gills are red.
Yep.
Oh yeah. Well, you tell us why the gills are red, then, sweetheart. Tell us about it.
Oh my god.
Oh my God. I'm listening.
I wasn't teaching. I'm sorry.
Oh, you weren't. Oh, okay. Well,
Yeah, I'm sorry.
we can come back to that when we get to animal physiology later on in, next year. Sorry about that. So the question is, why do we need oxygen? The next class, I'll explain why we need to have oxygen in order to stay alive. But the real reason is we have to make water. So oxygen reacts with hydrogen and it produces water and respiration. But there's more to it than just this. I want you also to think about this and think about this. So this is one of the very first questions I ever asked my spouse. So this is my spouse and these are my two children. And when I was dating, way back when, I would often, and not often, but always ask this question. And you guys can hear me, yeah? Okay, good. All right, because
Yeah.
okay, so I would ask I'd ask my dates. I'd say, well, why do you know? And I'm just trying to work it into the conversation. Why do you think we breathe? And then I would say, well, we need oxygen. And then I would, why do we need oxygen? And I'd act as if I didn't know the answer, right? Just so I could have a conversation. And it was really a way for me to kind of weed out some through people. So like if by the time you're in your mid-20s and you've done this process, like you take about 6 breaths a minute. You do this every single minute. And so 6 breaths a minute, 60 times an hour, and then there are 24 hours in a day. If you breathe and to inhale and exhale that many times over the course of your lifetime, and you never wondered why, and you're in your mid-20s, I wasn't really sure I wanted to date somebody that would not have thought about that, right? I mean, if you're going to sit around and breathe every day, why not ask yourself, why am I doing this? Why is this important? And when I didn't expect some scientific answer, but I did expect some curiosity out of somebody, because if I realized that when you're dating, you're going to want to find somebody that's hopefully as curious about the world as you are. And if they are, they might make a pretty good mate, somebody that you could spend some time with, because things are going to boil down to some, pretty mundane things. You're going to, your life's going to progress, and you're going to have conversations with people, and you're going to run out of things to talk about. But if you have a curious person, you'll never run out of things necessarily to talk about. Also, if they're going to be your mate, they're going to be potentially the parent of your children. And do you want a parent that's going to be at the boat ramp there and say, well, the gills are red on the fish because the gills are red? Or are you going to want to have somebody that a mother or father of your children go, I don't know, baby, let's go home and figure this out. Let's think about this. Are you guys still with me or not?
Yes.
Yeah.
Okay. I'm scared to death that I'm not coming through because I just had the call drop. So I really want you to think about that in that way. So there's a greater point to get an education other than simply earning a grade. I find that most of you guys are always worried about my grade. What am I getting in my grade? What is my grade going to be? And I want you to think about this, especially in the next year and a half, when you're getting an education, is how do I connect these dots from one discipline to the next? So when you have a greater view of the world, you often will get bigger views, and these bigger views could give you more beautiful views, and also sometimes will give you more terrifying views. You come to understand things and you're wondering, what in the heck? But when you find a terrifying view, then if you have enough understanding of the world, you can do something about it. You have enough, you're armed with enough education and understanding that you can start to change the world and not just become part of the world, but become a leader within it. Also, a writer doesn't become a greater writer because they understand less. The more you understand, the better the writer you become. An athlete knows that they should train at higher elevations because there's not as much oxygen. If there's not as much oxygen, they're going to need more mitochondria. That's why they train at higher elevations. The more you understand, the better athlete you can become. The more you understand, the better writer, the actor, whatever it is that you do, you connect more dots because you understand more and you become a better citizen overall. And you also never know, what is somebody going to ask you on a date? And where's that going, how that could change your life? My spouse is not a biologist. She didn't know the perfect answer to that, but she did say, oh, well, you need to breathe because you have to use oxygen to break down your food. And when you eat, if you don't breathe, you can't break down your food. And if you don't eat, your oxygen doesn't have anything to break down. And so you starve to death. And if you don't breathe, you can't break down your food. So you suffocate. She knew that much. And I thought, oh, bone of my bone, flesh of my flesh, I'm going to have to meet this woman and get to know her more. And as a result, I've got a family. So really think about things in a bigger, brighter way. Today is just an introduction. I'm going to start slow and then we're going to ramp up next class. Okie doke. So before photosynthesis is going to be the process that is going to store energy, respiration is going to be the process that releases energy. And so I sent you guys a photo the other night while I was camping, and I was showing you how I was basically oxidizing wood to reduce my food so that I could oxidize my food to reduce my body. And that's essentially what I was doing then. And that's really what all the respiration essentially is. Respiration, again, just to make sure that we're sticking with the law of thermodynamics, we're converting energy, and we're converting chemical energy also into chemical energy. We're going from glucose to ATP. There's also going to be some thermal energy that's going to be released as well. There's also, again, animals and fungi. We are examples of heterotrophs. And just as a reminder, heterotrophs are going to be organisms that are going to be consumers. We're also considered consumers. Consumers and heterotrophs, these two terms are synonymous for one another. They mean the same things. And because we eat other organisms because we're heterotrophs. All organisms that are not photosynthetic are heterotrophs. We have to kill something else in order to stay alive. That is, we are different feeders. Hetero equals different, troph equals feeding. We are different feeders. We have to eat something else in order to stay alive. We're using respiration to stay alive. We have to use oxygen to break down our food. Heterotrophs, again, just means that we are different feeders. We have to consume things. We can't synthesize our own food. Again, we're looking at the law of thermodynamics. We can never break the laws of physics. So the first law of thermodynamics is that energy is going to be transferred. I'm transferring the energy that's stored, the chemical energy in this gazelle. This sad little gazelle got killed by this cheetah. And this cheetah is now going to take this energy and transform it into other types of energy. So energy is always going from a state of organization to a state of disorganization. I release about 90% of what I eat as heat. So if you could touch your forehead, you'd feel your forehead, and that's going to be whatever you ate probably the night before or maybe this morning is being released as heat. Some of it is being stored as ATP, but you also release the carbon dioxide and the water from the food that you've eaten through respiration. We're just sticking with the law of thermodynamics for sure. Going back to your project that you guys are going to present in 6 days, you've got a plant cell, an animal cell. We have endosymbiosis 1 and 2. Endosymbiosis 1 is where you pick up the mitochondria. And so this mitochondria you can see is in both. So respiration occurs in all organisms. And this includes plants as well. Plants and protists have both chloroplasts and mitochondria. So you're going to have mitochondria there that are going to carry out respiration within plants and protists, even though they're photosynthetic. They're not producing sugars for us. They're producing them for themselves. They produce the sugars and then they release that energy there through the mitochondria. We don't have chloroplasts, so we have to kill something to eat it. But mitochondria and respiration are going to be carried out by all living organisms that are eukaryotes are going to be using mitochondria. For prokaryotes, they don't use the mitochondria to carry out this process, but all eukaryotes are going to be carrying out respiration with mitochondria, including, again, plants and photosynthetic protists. There are parts of the organelle, and these are some going to be, I know whoever has question number 1 should be already really aware of this, that mitochondria are really the descendants of prokaryotes. They live within our cells. And some of the characteristics that they have in common with prokaryotes is that inner membrane is that membrane that is very similar to that of a prokaryote. And the outer membrane obviously is not. That's where phagocytosis picked up that organism. But they do have 2 membranes, and there's going to be 2 areas. Because I have 2 membranes, I have an inner membrane space, and I have this matrix, this cristae, this area within the side of the mitochondria, and I can build up a gradient. I can build up higher and lower concentrations of molecules so that diffusion can occur, because I've got 2 areas with the membrane separating them for diffusion to occur. But the mitochondria, it does have two membranes. If we look at the formulas, it's pretty straightforward. It's pretty easy. You can see that respiration and photosynthesis are basically the inverse of one another, where cellular respiration has glucose and oxygen as reactants or substrates, that photosynthesis has glucose and oxygen as products. And where respiration has CO2 and water as products, photosynthesis has them as reactants. So these two processes are actually the opposite of one another. And it's by no mistake that that is the way it is. We are going to be taking the energy in this light energy, we store it here in glucose, and then we take that glucose and we release it into ATP. And I have these highlighted in yellow so that you can see this is the energy that we have in photosynthesis, this light energy, and it ultimately ends up here in respiration in these 36 ATP. It's broken down into 3 processes, and again, this is just an introduction. You do need to know that there are 3 processes that carry out respiration. The first one's glycolysis, second and third are going to be the Krebs cycle. So glycolysis doesn't occur, you'll notice, does not occur within the mitochondria. So where does glycolysis occur? If it doesn't occur in the mitochondria, where does it occur? And you can drop it in the chat. If it's not occurring inside of the mitochondria, where would it logically occur? And drop in the chat for everybody, not just for me.
Outside.
Where would it occur? Outside is not enough. Outside of the mitochondria, what's outside of the mitochondria? What? The cytoplasm, exactly. So outside, because these are organelles inside of a cell, outside of the cell is the cytoplasm, and that's where glycolysis occurs. Now, you do need to know this. How many ATP are produced in these processes? And we're going to get deep down in the weeds in this tomorrow, so it's always good to kind of start off with a superficial understanding. The process of glycolysis is going to produce 2 ATP, Krebs cycle produces 2, and the electron transport chain produces 32. So this is where things really get amazing. We used to, prior to endosymbiosis, we were just producing, and meaning we, organisms, were just producing 2 ATP, and that's not enough. That's not enough to really do a whole lot of work. You have glucose and you get 2 ATP out of it, well, that's nothing. That's like minimum wage. Imagine being on minimum wage and all you get is $7.25 an hour. This is like, and you get $34 more an hour. So, or 30, let's say 34. This would be like saying making $7 an hour, and this would be like making $500 an hour. You get to, and you're still doing the same job. You're still breaking down glucose, but instead of making $7 an hour, now you make $500. You're going to be able to do a lot more. So we were able to do everything that you've ever done in your entire life. Is all boils down to coming down to these 2 processes. The real payoff is these 32 extra ATP you get the electron transport chain. There's a ton of energy here, much more efficient, and it gives you the ability to do a lot more. There, we can invent things, we can have art. It's almost like the Neolithic Revolution. Well, I won't say anymore because that was one of your questions for your project. So we get to, if we look at it again, same thing. I'm looking at this from a different way, the model. We have glycolysis, glucose goes into glycolysis, but I'm really just making sure that we get that there are 3 different parts and where they occur. Glycolysis, again, in the cytosol and the cytoplasm. Krebs cycle here in the matrix, in the center of the mitochondria. And the electron transport chain is really happening in 3 different locations. It's really in that inner membrane, but there's an area outside the matrix, the inner membrane space and the matrix, that allows for this membrane to create a way for diffusion to occur, to really give me the payoff of all these ATP. You can see this looks like a bigger explosion. There's a bigger arrow. There's a bigger, looks like a firecracker exploding, indicating that there's more ATP being produced through the electron transport chain. This is where the payoff really occurs. This is like you graduate high school. This is like you graduate, you get an associate's degree. This is like you're graduating college, and you get a lot more money. We want to obviously make more money because you have more understanding. So think about the electron transport chain as really kind of being that kind of situation. Or you can think about this dropping out of high school. This is graduating high school, going from 2 to 4, and this is graduating college where you get a lot more. The electron transport chain gives you a lot more payoff. let's look at the formula in detail. So my substrates are in orange. My products are going to be, I think this is blue. That's what I think whenever I created this. So I wanted you guys, let's see, which side is more organized? I'll ask one of you guys in about 15 seconds. Let me see what I'm going to ask. Who is going to be the person? Let's go to, somebody I haven't talked to in a while. Let's go to Terry, man. Hey, Terry, which side looks more organized to you, the substrate reactant side or the product side?
The product side.
Okay, so why do you say the product side looks more organized?
Because of the pluses, and they're all out. It's like it's chopped up, I guess.
Okay, so chopped up. Let's stick with that for a moment. Let me ask you a question. I don't know if my video came back on when I came back. Let me see. Am I sharing my video? Nope, I'm not. Now I'm sharing video. I think. Oh, there I am. Can you see me, sweetheart? I don't know if you can see me. Do you see me?
Yes.
What am I holding?
A mug.
A mug. Let's say for a moment I decide that I'm going to bludgeon Earl. I'm angry at Earl. He's never had any, he doesn't like, what is it? He doesn't like dressing, stuffing and dressing. So let's say I'm going to bludgeon Earl with this coffee cup and I smack him upside the head and it breaks. You say it's chopped up. So I've got all this chopped up. Would you say if I broke this mug into pieces, the mug is more organized in pieces or as a whole?
It's more organized as a whole.
It is. Okay, good. So stick with me for that for a moment. So how many molecules of oxygen do you see on this side, on the substrate side? How many molecules of oxygen are right here?
6.
Absolutely. Excellent. How many molecules of glucose?
Of what?
Of glucose. This is glucose. How many molecules of glucose is C6H12O6? How many molecules of that is there? When there's not a number in front of it, you always assume it's what?
Oh, 1.
1. Okay, so 6 plus 1 is?
7.
Absolutely. Now, how many CO2s do I have?
6.
6. So 6 carbon dioxides. How many waters do I have? Molecules of water? 6. So I went from 7 to 12, and then I've got 36 ATP over here, but really we're just going to stick with these products and reactants right now. So I went from 7 to 12. This is, which side is more organized now?
The substrates.
Yeah, absolutely. You're correct, sweetheart. This is going to be the substrates reactant sides. They're more organized because they're in fewer particles. This is a balanced situation, and we're going to look at this in more detail next class. But this is a balanced equation. The same amount of matter in the reactants and substrates is the same amount of matter in the products. They're equal to one another. It's just that we're breaking this down. So would you say this is more oxidation or reduction? Let me ask somebody else for that. Thank you, Terry, for dealing with me for so long. Let's go to Taylor Tubbs. Do you think this is more oxidation or more reduction? If I'm breaking it down.
Can you repeat? I wasn't paying attention.
Oh, that's great. Would you say that this is more oxidation or reduction? We're breaking it down. We're going from being more organized to less organized.
Oxidation.
It is. It's oxidation. Oxidation is loss, right? We're breaking things down. So if I'm breaking this down and I'm losing and I'm becoming less organized, this is a real problem for organisms. We have to continually oxidize something in order to stay alive. I got to continually eat and continue to breathe. This is breathing. This is eating. And if I stop doing either one of these, I'm going to die. I'm going to quit producing these products. So this is a process that is going to be very important for us in detail. Again, this is the formula. This is a good little rendition of what it kind of looks like if you think about it in a holistic scale, on a global scale. I breathe, I produce water. All these are going to definitely be heterotrophs. And that water and carbon dioxide that's produced through respiration is picked up by photosynthesis and produces glucose and oxygen. We eat that glucose, we breathe that oxygen, and then we produce more carbon dioxide and water, and it gets picked up by photosynthesis. So essentially, everything you've ever eaten was something's breath. I don't know if it was a rabbit's breath, a chicken's breath, a dog's breath, a cow's breath, a human's breath. I don't know where that carbon dioxide was. It could have been a bacteria decomposing a turd, but you definitely, it got turned into glucose, and then you've eaten it. And I'm sure that you guys have we've all eaten glucose that was definitely carbon dioxide that came out of a turd at some point, probably every day, if you think about it. But it's pretty amazing. To me, I think it's very beautiful. It's very poetic, if nothing else. We've got a few minutes. I'm going to see if we can't play a little game. Again, this is not for a grade, but let's just see how well you guys can do with a little bit of a game here. We're gonna play really quick. What time is this class out? You guys take a look at the schedule. I'm a little nervous about how much time we have remaining. How much time do we have remaining?
Class ends at 11:03.
11:03, that's 7 minutes. Oh, we don't, there's 20 questions. There's no way we can do it. Sorry. There's only 7 minutes. Okie doke. I will share, and I do think that you guys might want to, if you get in study groups, you do have a final exam in a couple of weeks. And I do want to remind you, if you're only coming to class and this is the only time that you guys are working together, you're walking into a chainsaw. You have to start studying for your exams weeks out before you take them. So you should have 6 final exams in 2 weeks. Ours is going to be cumulative. It'll be biomolecules, respiration, photosynthesis, eukaryotes, prokaryotes, Tracy, diffusion, osmosis. There's a lot, right? There's not as much as there normally would be because we're 1 unit behind for the year, or at least for the semester. We'll be 2 units behind for the year when we come back for next year. So we don't have time to review. What I do recommend is that you guys do and come in and you start kind of picking up doing your own thing. So today, I would have played this and our class had been cut down by 10 minutes and we only have 7 minutes remaining. So I'm not going to try, but I do have a game here. It's just a little quiz is, and you could just practice with your friends, form study groups, come in here and you can start and do these things on your own time. Don't just use class as a time that you study. We don't study in class. We learn new things in class and then you study on your own. That's why we call you students. Students, the root of that is study. You're not a student if you don't study. You're not a student if you come to class. My cat's in here with me right now. It's in class. It's not a student. So you do want to take some responsibility and maybe you would come in here with your study group, meet online, practice this quiz and just kind of break these things down and see what it is you do and don't understand. Now, do not be late. Several of you guys came into class 6-7 minutes late. You should be hopefully better accustomed to the schedule next class. It's going to be important that you do come in and you make sure that you're here on time for the very next class, because we are going to get into the weeds in the very next class. And then you guys have your presentations the following Monday. So I'm going to stop. I'm going to let you guys field any questions to me that you need to. We have 4 minutes remaining. What questions do you guys have that I can go over? And it can be over anything. It can be even over the PowerPoint I just went through. I know his introductory material wasn't that complex, but still it might be a lingering question.
I have a question about the project.
Go for it.
The minimum amount for the video is 3 minutes, right?
The minimum?
Yes.
The minimum recommendation was 5 minutes. I don't know that you could do a video over 5 different topics in 3 minutes. That would be really, really compressed. I can't imagine. Usually, how many minutes was the example that I emailed you guys?
5 minutes.
It was 5 minutes. 5 minutes. What again?
5 minutes, like and a half or something.
5.5 minutes. So yeah, and they did a pretty good job. I would say probably 5 is about the low end and 10 is the high end. I mean, there's 5 groups and we only have 50 minutes, right? So we're going to watch all of your examples that you guys have made for us. And I would recommend uploading them to YouTube. That way you can just drop the link into the chat and then we can just pop and just watch them all. You'll submit your rubrics afterwards, the reflection rubrics. And this is where you can remember you grade yourself as well as your classmates. So let me go back. So this is where you find it. So this is your rubric. When you open this rubric, I don't know, did it jump to the rubric? You guys can see it? Yes, no, maybe so?
Yeah, we can.
Yeah. So you're going to come in here, you're going to assess yourself as well as your partners. And if you're in a group of 6, then you can just make this you can make another column. You can change this rubric and make another column for you, add another column for you if you're in a group of 6. And just put their name of the person up there. And this is where you're evaluating your peers. And this is completely anonymous. I'm not going to share this with your peers. I think you guys probably should. It gives them an opportunity to grow, but that is for you. When you submit it to me, I won't share it. You guys are welcome to share it as well. But be honest. You need to be honest about yourself and then be honest about your peers. Like I know there several of you guys were saying, well, my peers aren't reaching out to me. I've been trying to contact them, but they're not contacting me. I don't have anybody, and so I had to get involved. That doesn't bode well. That doesn't, for that person. But maybe they came in here and just killed it. And I think I explained it pretty well in that email that I sent you and your folks too. Any other questions? We still have 2 minutes. I've also, there's somebody asked, do we have to use the dry erase board? No, of course not. I've never seen this done the same way. I've never seen anybody do it the same way. I've never seen that question about comparing it to the Neolithic Revolution and the American Revolution. I've never seen those questions answered the same way. I've never seen any of those people take the same view of it. So you probably shouldn't have copied. I hope you didn't copy what their take on the Neolithic Revolution and the American Revolution. You need to come up with your own ideas and really kind of discuss it. The more you think about things, the more dots you can connect, the better you see the world. And that's really what that is about, trying to break things down and see connections between or analogies between science and literature, or science and history, or math and history. How do these things play out? Why is the world the way it is? And then try to think about it through different lenses. All right, I'm going to leave you guys be. Do not be late next time. It is going to be a lot, and I want to have time for us to practice. So do not be late in the next class. You guys be good.